So what do we have on the bench tonight? Hey, it's a Zenith portable from the 1950s. Just what you need to take down to the beach with your girl. This one's a little special, because the chap I got it from told me he mucked with it. Was it the king cobbler playing with it? Or was he just a little bit over his head and didn't know what to do? Stay tuned to find out. Okay, so when I got this particular radio, it was already taken apart. Doink. So we can put this away for now. We can deal with the chassis, the cabinet, or I guess in this case the nice leather case, full leather case, really nice, really high quality leather. We can deal with that one later. I put that out already. It's already came taken apart. And as you can see, it came with the original batteries, the 90 volt B and B plus voltage battery, and I think this is 7.5 N9 C battery. I check and see if that still works, but those aren't going back in because the chap wants it, who owns this, wants it in AC. And as you can see, he's done a little work on it, taking a few caps out. And a quick look underneath to see what he's done. We'll zoom in here a little bit. Zoom, 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 zoom. Okay, so he's just taking out what looks like a little pokey stick when you need one. He's putting that cap in there. Alright. That looks okay. And there's one, I think, oh yeah, there it is, stuck under there. Okay, so it's not too mucked up. Good. It looks like he did a fairly good job. And we can carry on and say we can fix this radio. Now I did ask the fellow if he'd ever tried to power it up. He said he did try to power it up with the line cord, but he couldn't get any power out of it. But this does have a switch here, according to the schematic, that controls the battery or the AC power. And I think probably he didn't know better to change that switch around, so I don't think it was ever charged up with AC, which is a good thing because he could have blown that selenium rectifier fairly easily. I don't think that was ever been turned on. No evidence of heat or anything around it. Anyway, so the other big point to notice is a huge big electrolytic cap, a 3 electrolytic can. He wants to leave that in so it looks original. We can do that for him easy enough. Problem is not a lot of room inside the chassis to put anything, so I might have to re-stuff it, but unfortunately it's riveted in there, which would be a big job to screw out those rivets and replace that can with something similar. So I have to work on that a little bit. The other thing to note is the speaker. Nice and soft. We'll zoom in here. The speaker is in pretty poor shape. Lots of cracks and it's pretty brittle. It's cracked there, there's a crack in there. And the paper on the side is beginning to break. So that's going to have to be repaired. Right away. So before we get started, I'll pull the tubes. They all look in perfect shape. And then I'm going to put a piece of cardboard, of course, over my speaker so I don't dent it when I'm playing with it, as it doesn't really come off. So we'll go do that. Okay, so tubes are all out and neatly placed away, and I got my little protector on that so I don't poke a hole in that by accident. So, what next? Well, what I should do is I want to make sure that it is repairable. So I want to basically ohm out the coils. Well, there's nothing really interesting in watching me ohm something out, so I think I'll take this opportunity to first give a shout out to Terry out at D-Labs for his cobbler. I love using that when I can. In this snippet, all I'm doing is a simple continuity check across the two IF cans and the oscillating coil.
Now you check for continuity across one side of the oscillating coil and across the other, and the two cans are tested in exactly the same way. Now this radio also has a 445 kc wave trap. Now you don't want to get this confused with the oscillator coil. Now at the time when this radio was built, marine broadcasts were still done at 445 kcs in Morse, and you really don't want that interfering with your AM broadcast. So the wave trap bleeds this signal off to ground. Nowadays this frequency is no longer used by anyone, so you can ignore any problems with this coil. Looks like I'm almost done with my checking, so let's go back to the regular broadcast.
That's good. He didn't muck anything up when he was doing it, so we're ready to do it. What comes next in our list? What I want to do now is get in there and figure out a way to replace that cap without destroying everything. It is in there tight. So, first I'll find out what is the replacement parts that have to go in there. And according to the Ski-O-Matic, that can has, where is it? Paper everywhere, but not a drop to drink. Oh, there they are, hiding under here. That's an interesting way to do it. So it's 80, 20, and 200, a 10. Interesting. So the 200, way over here, goes all the way up to the cathode of the IF4, so that must supply A voltage. So it's got cathode biasing. Give it a little B+. Put it below that, I guess that's what it's doing. Don't know. So it's an odd value. Alright, let's see what I got in the old capacitor box. Okay, so I've done a few things since I got into this now, after I finished ohming it out and found that it's fit to fix. I ohmed out where all the wires go from the cap and which cap goes where. And then of course I wrote out where they go on that piece of paper. And then as I was doing some more ohming out, I figured out that this switch is very weak. So that switch will probably have to, let me zoom in, you can see that. Yeah, zoom. Didn't focus, okay. Anyway. So there's the DC switch. And it's not working correctly. As you can see, right here, it doesn't make full contact. You actually have to push down to make it go full contact. So there's something either blocking it or stopping it. And of course the other thing is the selenium rectifier and the line cord, which is pretty screwed up to check out. So, plan of attack, I'll zoom out again, is quite simple. Number one, clip out the cap and replace that with the other caps, which I figured out how to go in there. I'm going to put them in a big bundle here, well insulated and well away from everything. They should fit. At the same time, clip out the power cord. Try to save this knob. And then, once I get the cap done, I can go in and remove the leads to the rectifier. Leave the rectifier in. Place the line cord. Once I got that in, then I can do the test and set up the value for the resistor. Anyway, I'll go over that next part. So, right now I'll go in and clean up that part right there. Clip that up. So, back with my caps. That's an 80 at 160. It turns out it's a 20 at 120. 160 is fine. And a 200 at 20. But I've got a 220 at 25, so that shouldn't matter much, I hope. So, gotta find a way to put those in there somehow.
As no one really wants to watch me change out caps for the next 15 or 20 minutes, I'm going to interrupt again and try to explain why this particular All-American 5 would in fact have 6 valves if it had a rectifier valve. But in my case it has a selenium rectifier, so it's only 5. This 5-tube super heterodyne design goes right back to the beginning of the Zenith Radio Company. It's actually started in two guys' garage. They specialized in making high-fidelity battery-operated radio. Zenith was also famous for the quality of their radios, both in the quality of their cabinets, or in this case, leather box, and the quality of their sound reproduction. Even I remember from when I was a kid their famous slogan, "The quality goes in before the name goes on." Anyway, back to Wi-Fi valves. First we start out with an RF stage with the 1U4 valve. Now why do we have an RF stage? Well, for a number of reasons. First, you can use a much more compact antenna. As well, the low filament voltage limits how many electrons can actually be cooked off the cathode and used in amplification. This might seem like a drawback. However, because of the low emissions of this valve, there is no need to put a large amount of voltage on the plate. Therefore, in a battery operation system, we can use a smaller B+ battery and get much longer battery life. The rest of the valves are just like any other All-American 5, with a converter followed by an intermediate frequency amplifier. Next, of course, the detector amplifier, and finally our power amplifier after that. Now you notice here that the power amplifier is 3 times the filament voltage of the other valves. And the simple reason is you need a lot more power to drive a speaker with any volume. Now with the low filament voltage and low B voltage on this radio, the battery life is said to be over 500 hours. Try doing that with any transistor radio. As well, the batteries for this particular radio were relatively small for the day, given that some radio batteries could weigh well over 5 kilos. Now, I was going to take a look at the automatic volume control circuit, but the way it was written, I couldn't really figure out how it works. Looks like I'm going to have to get somebody from the radio club to explain that to me someday. So that's about it on Wi-Fi valves in this particular radio. And so it looks like I'm almost finished with those capacitors, so let's go back to our regular program.
Okie dokie, all set up. So I managed to get them all wired in there without too much ado. I had to move a few wires around, do a lot of clipping. I took that one out that was there originally and put in a safety cap, a nice YX cap, and I was going to check the continuity. I replaced that one because this one here was the death cap going right to ground. So you can see that goes to ground. Chassis ground goes right to there from the power supply. So anything on this side should be going to ground. Ground. That side and there. Don't have anything on that side, so that's all working correctly. Good. So take off that cord now. Okay, so I managed to put in the new line cord here. And all I have to do is put a click like that, and then a diode between here and here, but a resistor after the diode to take care of that. And I think I'm all set to go. The other thing I have to do before I go on to fix that is go and have a look at that switch and see why it's buggering up. But so far everything's okay. I'm going to go do a quick clean of the switch first with a little deoxit. That might fix it up. And we'll see what happens after that.
So while I'm busily fixing that switch, I'm going to explain the setup for doing a selenium rectifier swap out. Now the reason why we take the old selenium rectifier out is that if they ever go pop, and they will produce tons of very noxious and actually very toxic smoke. They can be replaced by almost any of the 1N4000 series diodes. I think I used the 1N4004 in this radio. Of course, the first step is locating where the selenium rectifier is on the schematic and confirming that it's a simple half-wave rectifier. You have to be careful on some of the more elaborate radios, as some of them used full-wave rectification seleniums. Next, we just clip out the selenium rectifier, and then we put in our diode, followed of course by a resistor. That's going to account for the larger voltage drop across the selenium rectifier. Now in this case I selected a high value resistor of about 400 ohms, as the valves on this radio have very low filament voltage and it's really easy to cook them. Now we have to set up for finding the filament voltage, and all we do here is find the valve that is in the middle of the filament series and then connect a voltmeter from one side to the other. In this case it's the IU4 intermediate frequency amplifier, and we connect up between pins 7 and 1. Once this is all done, we can hook up to our variac isolation transformer and a dim bulb current limiter, and very gradually raise the voltage up with our variac, keeping a very close eye on the filament voltage. So it looks like I'm done fixing the switch, so let's continue on with our regular program and get that rectifier swapped out.
Okay, just about ready to start the test for the selenium rectifier. I've made sure the switch is on, because I fixed that, cleaned it all up. Do a little bending to get it work 100%. Turn the switch on. Make sure power is on. Power cable's been all assembled. It's plugged into here, into the variac. through of course the dim bulb, through of course the isolation transformer, I should say, not the dim bulb. I've got my DC voltage measuring across pin 7 and 1 of the middle valve. I've got my diode set up with the power coming in here, going out there through this resistor. I've started with a high value resistor, 5 watts, 400 plus ohms. That's my line voltage coming in. That is, of course, the voltage on that thing. I'm going to go throw the switches now and very slowly bring the variac up. So there we are at 25 volts. Not much, if anything, flowing yet. There we go, 0.1, 2, 3. Ooh, negative voltage. What am I getting a negative voltage there for? Let's look for that. That's not right. Let me check that.
Much later.
So after playing around for a while, I finally discovered that my 1U5 valve had a blown filament. So off to the radio club to get a new valve. Like I said before, you never want to go over 1 volt on these 1 volt tubes, even though the data sheet says 1.4 volts. Anyway, back to our program.
0.2 millivolts, so still not enough voltage.
Much later.
So it seems to be the never-ending story with this particular radio. Another tube is gone. In this case, it's the one of the 1R5s. And why that caught me was because in a 1R5, 1 and 5 are also joined, as well as 1 and 7. And I also found out from one of my Radio Shack, Radio Club guys, is that these 1 volt tubes, if you put them on a tube tester, they tend to get fried on any modern tube tester. It's really only the old tube testers with the really low voltage that can actually test these. So what more than likely happened is somebody tested these and fried them when they were testing them. What happens, according to my buddy, is that you test them and they test fine for a few minutes, but basically it's too much voltage and they get burned out. So what I've had to go do was I put yet another new tube from the Tube Shack in the system, but I want to eliminate the chance that something is miswired in here where I'm getting way too much voltage on the filaments and burning them out. Yeah, so I've got the function generator hooked up to this, and I've got a triangle stepping wave running through there at about half a volt, running through my power supply at about half a volt at 10 kilohertz. So that should just go straight through the system without any of the parts really being affected, so the capacitors or whatever. So I should be able to trace that signal all the way through. And I got the handy dandy oscilloscope over here, and if I touch it there, I see my nice triangle wave. I hold it still. Then I can go to the first tube down here, touch number 7. I should see a triangle wave, a stepping wave, a little lower voltage. Yep. Another one here. Get in there. Yep. Next. Yep. 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 Oop. Declip, but that's okay. I'm getting some attenuation at the far end. Yep. And yep. Okay. Okie dokie. Now we're set up finally. Got all the tubes checked. Voltage coming in. Voltage across my middle tube. Put my power on and slowly ramp her up. Now I've got the 400 ohm resistor in there. 12, 20 millivolts still, millivolts. We'll bring her up to 50. What's the volts DC? AC. course, it's DC volts we care about. Still in millivolts, so it's way too little. We'll bring her up to 70 volts, 8, 9, 80. Still only getting 100 millivolts. And we'll go up to 110. Only getting 100 millivolts across there. We want 1 volt. It's off. No AC. So, 400 ohms is too great. We'll switch everything down. Back down to 0 volts. Double off. And we'll swap out the resistor.
Much later.
So after playing around with lots of different resistors, I finally found one that kind of fits. About 115. So when I boost up the power, 10, 20, stable at 75, 78 volts, 62, we'll go up to about 100. And if we just start going 110, 120, we get 1.2 volts or 1.12 volts, and of course it'll vary all the way up to 120, and it'll vary always down to there. So we get 1 volt, and that's basically all we need. So that's the resistor picked. Yay! Now I can hook it all up and try to debug it more.
So let me interrupt one more time while I'm busily soldering up that resistor and diode in place. One thing that surprised me about this radio is that the filament voltage is DC, not AC. And that explains why we have a large value and low voltage capacitor in the power supply. Now if you add up the filament voltages, it comes up to 7.4, which is just a little bit below the standard battery size of 7.5 volts. You'll also notice that there's a center tap on the 3V4, and the voltage coming off this center tap is used to bias the IU4 intermediate frequency amplifier. So with this neat little trick on the valve, the designers did not have to put in a C battery for biasing. Anyway, looks like I'm almost done putting everything together, so let's continue on with our story.
Alright, so fixing a speaker like this is actually a rather simple process. All you do is you get some wood glue and you water it down really, really good. About 10 to 1, 15 to 1, so you just get a gluey solution. Then just ordinary tissue paper. 2-ply, and you try to get a second ply. Usually 1 ply will do. Get the second ply out of that. There. What you don't want to use is the tissue paper that got oil on it. So this is just straight normal tissue paper. You just rip off a piece about the right size of what you want to cover. Stuck to your fingers really easy. This really is just to strengthen it. It doesn't actually fix it. Just strengthens it up so it doesn't rip anymore. Take the glue. At the surface. Come on. Oh, I'm bad at this. Ruined that one. Try again. Always lots of paper. Oops. That's got a lot of capillary action on it, doesn't it? Ugh. Third time's a charm, they say. That's strange. I've never had this much trouble before. There, just dab it on. That, it's got to be the hardest one I've ever done. Usually just takes 2 seconds. Little butterfingers tonight. Hey, try one more time here. Little butterfingers tonight. Then, once you get it down, you smooth her out and try to get rid of all the wrinkles. That will stop it from ripping. Is that a hole there? No. And then you just let it dry. And then there's a 2-step process to this, because you got to recondition the paper. Oop. The sides are coming up. You can just glue that in there like that. Doesn't harm it at all. Okay. So, let that dry. Clean things up. It needs a little bit of alignment. I'll put it back in the box and I think we're done.
Much later.
Now after I've let the tissue paper and glue mixture dry for about 24 hours, I then coat the old speaker with a speaker service cement. Now some restorers out there balk at this because it looks really ugly afterwards and they claim it destroys the fidelity of the speaker. Now I do it because it's going to stop any further deterioration of the speaker cone. And as the speaker doesn't really have a lot of high fidelity to begin with, it's not going to affect it very much. Anyway, let's go on to the next part, the alignment.
So all set up for the alignment. I don't think it's going to take very long to align this thing. Anyway, in this case, according to this chart, I hook into pin 4, which I've done through here, through this cap. I've got my trusty old RF signal generator running on the other side. We'll turn her on. Ooh, lots of hum. Let's put the modulation in there. Whoa. Let's see if we can tune that up at all. Down, no. No, I think that's pretty good just the way it is. Don't think I need to change any of that. Good. Well, that was a quick alignment. Let's put her back in the box and see if we actually get any stations. Oh.
Stock 580 CFRA is a presentation of Walker Real Estate with Walker Gets It Sold.
Not bad. That's 580.
So actually that's about it. There was no reason to do a dial or tuner alignment, as the tuner dial doesn't really have any numbers on it anyway. All I really had to do at this point was solder back on the antenna and then put everything back into the box. In the end, it was a pretty neat little project. The Zenith radios were really well built with some really innovative features. As well, the guy who did the initial little bit of work on it wasn't a cobbler at all. He was actually a fairly good technician, as he stopped working on something before he got into real trouble. I learned this lesson a long time ago from my father. When in doubt, ask. Or, if you can't do it, get someone else who knows how to do it to show you how to do it. One of the other interesting things I found out while doing this project, it seems these Zenith beach radios are quite the rare thing to find, at least in the condition I'm dealing with here. Seems going to the beach, which is wet and salty, isn't good for radios. And of course, these things were handed down to the kids, and they were just abused and basically destroyed, or thrown away once the batteries died. So it's quite rare to find one in fairly good nick to begin with, and one that's actually working. So the owner of this should be really proud to have it in his collection. Anyway, that's all for this one. I'll see you on the next project.
Riley, what do you want to work on next? Valves or transistors? Transistors, and then valves. Okay. Riley, is it nap time now? I don't even want to help. Okay. Talk to you later.